Hello and welcome. In this video we will be measuring segments. Okay, we've seen this definition of segment before, but let me read it again. It's the part of a line consisting of two endpoints. So here you see, once again, a line, arrows in the end implying continuity. This line goes forever. If you want to have a segment or a portion of it, you just cut it off at any 2 points. Here we have points A and B. We could create that segment right there, and then we have something of finite value. This is an actual measure of length that is not infinity. In fact, this one you actually can see clear as day. This number seems to be 8, the distance between 10 and negative 2. But you won't always get those numbers specifically. It might be a little more vague. So there are different ways to measure a line segment. Let's go through a few of them here. So let me read off this little definition put down here. The distance between any 2 points is the absolute value of the difference of the distances of those 2 points from a given reference point. So that's a bit wordy, but let's clean it up just a little bit here. So the distance between any 2 points, let's pick B and C. Here's point B, here's point C. We want to find the distance between them. This one's kind of easy to see. The distance is 5. 1, 2, 3, 4, 5. So let's confirm that by showing it in a different way. So the distance between any 2 points is the absolute value of the difference of the distances of those 2 points from a given reference point. So the absolute value of the difference, that means somewhere we're taking an absolute value and we're going to do a subtraction. So we need to find out how far away these 2 points are from another point. Okay, this might help you in some scenarios. Sometimes you do know what it is, sometimes you don't. Let's use A as that reference point. Okay, so from A, the distance from A to B, here, this segment length is 8. Let's say you were given that. Let's say you were also given the distance between A and C, the reference point, and your other point. And that one, if you can count that, from negative 10 to 0 is 10, from 0 to 3 is 13. So that distance is 13. So to find the distance of BC here, we're going to subtract the distance from one of our points to the reference point, AB, with the distance from our other point with our reference point, AC. So AB, that length is, let's do BC, that length is 8 minus 13. And 8 minus 13 is negative 5. Now, distance can't be negative. That's why we're doing the absolute value. So the absolute value of negative 5 is 5. That tells us the distance between points B and C is 5 in either direction, right? C is 5 units away from B in the positive direction. B is 5 units from C in the negative direction. Doesn't matter which way. That value is still 5. That's why we take the absolute value. And this was a perfect example because I chose the smaller number first and subtracted the larger number from it. Would it change if I did AC minus AB? No. You still do 13 minus 8, and you get 5, and the absolute value of 5 is still 5. So it doesn't change. So that's kind of just what that definition means. You can gather things from how far away 2 things are. Let's say you're standing, say you're playing on a baseball diamond, and you're standing at 100 feet away from home plate, and another person is in line with you and is standing 40 feet away from home plate. Well, you two are 60 feet apart. Right, same idea. You do subtraction. Okay, I'm going to do one more thing with this slide here. Let's look at B, C, and D and kind of do the same thing. This time let's choose B as our reference point. And we know that BD is 10 units long from negative 2 to 8. And then CD is 5 units long. So if you needed to find what BC was, same idea. You can do subtraction. You can say that the length of BC here is the length of the absolute value of the length of BD minus CD. So BC is the absolute value of 10 minus 5, which is 5. So BC is also 5, just like CD is. Now that helps us determine one other thing. C is the midpoint of B and D. If C is on the same line, if B, C, and D are collinear, and C is between B and D, and if the length of BC is equal to the length of CD, then C must be the midpoint of B and D. Now notice throughout this whole thing, I haven't put any bars above what you might have thought were my segments. And these are segments, but I'm not referring to the segment itself. I'm referring to the measure of the segment. The segment provides two things. It provides the actual figure and the measurement. So a segment is not only how far it is, but it's which way it's going, and it's what color it is, and everything like that. You know, the way it's oriented. The measurement is the only thing I'm caring about here, and that's those actual units. Okay, and that does bring me to my next term here, which is congruence, and it's used with this symbol. It's like an equal sign, but with a squiggly line above it. Congruence means same shape and size. So the difference between something being congruent and something being equal is that equal might mean that every single property of that identity is the exact same in terms of its measurement. However, congruence is not just considering measurements, it's considering the shape as a whole, but it can be oriented differently. So take, for example, these congruent figures. I went to Google Images, typed congruent figures, and this is what came out. So all these shapes here, this quadrilateral LMNO is congruent to the quadrilateral WXYZ. The triangle ABC is congruent to triangle DEF. Although they're rotated differently, although they might be a mirror image of one another, although they might have different colors, the sides are congruent to each other. There are corresponding sides which are congruent, meaning they have equal measure. Okay, despite the fact that they're oriented differently. And the angles are also congruent with one another. It gives you the opportunity to overlap one on the other if you rotate it and flip it and whatever you do and give it the same color. So they can look identical, but in this case they're just congruent. Here's one example of not congruent. I don't know what that one is right there. But most of these shapes you can see are all matching up. So what's an example of congruent segments? Let's say we have these measures A, B, and C, D. Now you have no proof anywhere here that these are congruent or that the measurements are the same. You can't look at something and assume that they are. You have to be told it in some way. So what if you're told that these are each 10 centimeters long? And I don't know how far they actually are. Plus your computer screen is different than mine. If these are both 10 centimeters long, then that means that they're both equal in value. The length of AB, of segment AB, so this measurement is equal to the length of segment CD. And if that's the case, then that means that the segments themselves are also congruent. And if you want to mark that in terms of congruence, you would do something like this. You'd give an equal sign thing like that, or you can give one tick mark, or if you have multiple ones, you can give 3 of them. Look at this triangle down here. If I wanted to measure corresponding parts being congruent, I'd say AB is congruent to DE, BC is congruent to EF, and AC is congruent to DF. So notice those tick marks there. I tried to do them straight. I gave 1 with 1, 2 with 2, and 3 with 3 to say that those are the parts that are congruent. Okay, let's do some examples with what we were talking about before. We were using segments, and there were points that were collinear. All right, now this one doesn't have any drawings here, so I'll go ahead and draw it based on what they tell us. Points A, B, and C are collinear. Point B is between A and C. So I'm going to draw a line. I'm going to throw in some points. There'll be A, B, and C. Okay, AC, that entire length right here is 3x plus 3 units long. Obviously an unknown because there's an x. AB, that length is -1 plus 2x units long. And then BC is 11 units long. Okay, much like we did in the previous example here, as we did subtraction from a reference point to find something, you can also do addition in the same way. In fact, this is called the segment addition postulate. If I want to find the length of AC right here, and B is on the same line as A and C, if A, B, and C are collinear, I can add AB with BC to get the whole length of AC. I think I even touched on that in the last video, and that might have been by accident. So here what that means is if I want to find the length of AC, and not necessarily I need to find that length, I need to find x. But in order to do that, I need to create some sort of equation. And the best one that I can do is some sort of addition problem where I can say if I add AB with BC, I will get AC, that entire length. Okay, now I'm not going to use absolute values here because this is addition, it's not subtraction. So AB is -1 plus 2x, BC is 11, and AC is 3x plus 3. From here, we can solve for what x is, and from there we can also find out what the whole length of AC is and what AB is as well. So -1 plus 11 is 10. You have 2x plus 10 on the left side and 3x plus 3 on the right side. Subtract 2x from 3x, you get 1x. Subtract 10 or 3 from 10, you get 7. So x is 7. Now we're not done with the problem. We still have to answer the question, what are AC and AB? Let's go and do AB first. Substitute 7 for x here, and you'll get -1 plus 2 times 7, which is -1 plus 14, which is 13. So AB is 13 units long. You can find AC by substituting 7 the same way. You'll get 3 times 7, which is 21. 21 plus 3 is 24. Or, now that you know what AB is, 13, you know that BC is 11, AC will be 13 plus 11, which is 24. Either way works, you still get those same numbers. And these are measured in units. We don't know anything else about it. Okay, number 2. AC is 22 units long. BC is x plus 14 units long, and AB is x plus 10 units long. We're falling under the same assumption that we're setting it up like this. So A, B, and C, one more time. And if you take a look at number 1 again, AB was shorter than BC by appearance, right? The distance from here to here is shorter than here to here. But if the number tells you it's longer, then it's longer. Okay? So AC is 22. BC is x plus 14, and AB is x plus 10. Same idea, once again, you want to solve for x and then figure out the lengths that they are asking you to find. So I know that AB is x plus 10. I'm going to add that with BC, which is x plus 14, and I get 22. So let's solve for x. Combine like terms. You get 2x plus 24 equals 22. 2x equals -2 divided by 2, you get x equals -1. So if x is -1, let's substitute that into both of these. -1 plus 10, -1 plus 14. 10 minus 1 is 9. 14 minus 1 is 13. And to confirm that, 9 plus 13 is also 22. So it looks like it all got set up correctly. I have 3 more examples for you. This one, you now actually have the figures. These ones actually might even be easier in this sense, but I want to transition this to number 5. You'll see how it is. So you have B as the midpoint of AC, segment AC. Let's find the length of AB, the length of BC, and the length of AC. So you might start going off by saying, well, if I add AB with BC, I get AC, which is true, but I don't have anything here to say what AC is. You might be going like, well, I don't really know anything about it. You know that you can add a 2x plus 7 with 5x minus 14 to get AC. But once again, you know nothing about AC here, so you can't solve for x that way. What other information were we given? You were given that B is the midpoint of AC. And if B is the midpoint of AC, then that means that segment AB is congruent to segment BC. And if segment AB is congruent to segment BC, then that means that 2x plus 7 is equal to 5x minus 14. These two lengths here must be equal to each other. So we're going to create an equation where 2x plus 7 equals 5x minus 14. This way you can solve for x because of this knowledge right here, this information that they give you. Solve for x, subtract 2x, add 14, and you'll get x equals 7. When you get x equals 7, let's go ahead and substitute to find these 3 values. So AB, let's make it a little, equals 2 times 7 plus 7 equals 14 plus 7, which is 21. Okay. And then BC, look, you could substitute 7 again, but AB is equal to BC, right? So BC also has to equal 21 because it's equal to AB. And how long is AC? Well, you can add these two, 21 plus 21, or once again, just recognize that if these are the same, then you just double your number. So 21 times 2. I'm sure 21 plus 21 is as easy to obtain, but again, that recognition is really key to understand there are multiple ways to do a problem, and you want to attack all those ways. So we found AB, BC, and AC. Okay, number 4, find the length of MK, okay? So, of segment MK. So, finding the length of segment MK is the same as saying find MK. Notice how I didn't put a bar above it. So, these both mean the same thing. All right, so they're asking us to find out what this is specifically. So, although the question isn't necessarily harder, even though it's broken up into 3 parts, we're going to add these 3 things together, x minus 6, 9, and 2x minus 19. That's all equal to this entire length of 23. So although that's not necessarily more difficult, maybe the question is tricky for 2 reasons. One, it says MK instead of KM, and I want you to recognize that they're the exact same thing. And 2, it won't be negative, in other terms. And 2, you need to make sure that you really see what they're asking for. They don't say solve for x. You need to solve for x to find the rest of this problem here. Plus 3 minus 19 is minus 16. But you need to answer the question that's being asked. So there's the trickery that's being employed here. Plus, this is the first time that you're seeing something, the length of the segment, as opposed to find this and that. So again, just attacking all the different words so you see every single type of problem. So solving the algebra, you get x equals 13. Now we have to find this length right here. M from M to K. So if x is 13, this is 13 minus 6, which is 7. So the length from M to K, or K to M, is 7 plus 9. Which is 16. Okay. They didn't ask for MN. If that's the case, though, then this length here would have to be 7, which is 2 times 13, 26 minus 19, which is 7. Because 16 plus 7 is 23. Okay, one more problem, and this one's a bit of a doozy. We have to find all of B and E. Now, you're given the length of BC. You're given the length of DE. You are not given the length of CD. You're given the length of BD, and you're given the length of CE. So in the previous problems, you were able to find the entire length of this thing. I mean, at least in some terms, BE. And it would be nice if we could do that, but the problem is there's some overlap right here. And there's no assumption to be made that this portion here is just x, because this contains x in both of them. You need to find how long that overlap is with the information that you're given. So here's what I'm going to do. I'm going to go ahead and use these 2 values to find out what CD is. If you remember the very first slide that we were looking at here, to find the length of 2 values here, you can choose a reference point such as A, subtract this length with this length here. So I'm going to do the same thing over here. To find out what CD is, I'm going to subtract BD with BC. And then I'll get the length of CD. So CD is equal to the absolute value of BD minus BC. So CD is equal to 27 plus x minus 3x plus 47. Now, there are parentheses here because I'm subtracting this entire quantity. So I don't want to just write minus 3x and then plus 47. I'm going to have to subtract the 47 as well. So CD is equal to 27 plus x minus 3x minus 47. Okay. So CD is the absolute value of 27 minus 47 is negative 20. X minus 3x is negative 2x. So CD is this length here. Now, once again, that doesn't really progress you any farther unless you can compare it to some other value of CD. And you can do that using these values here, DE and CE. So you can see CE is x plus 26, DE is 10. So if we subtract those as well, now we'll be in good shape. So we have CD is also equal to x plus 26 minus 10, which is x plus 16. So we have two different ways that CD is represented, as negative 20 minus 2x and x plus 16. These absolute values won't end up being very necessary here because we're referring to variables, and it's the same thing on both sides. Like we have absolute values of the quantities on both sides. So if we set these CD values equal to each other, we can now solve for x. So if I go ahead and I'll add 2x over here, we get 3x equals, and here I'll get negative 36, and then we get x equals negative 12. So that's now the value for x. Now we have to use that and substitute it in somewhere to start working on how to get the entire length of BE. So here's how I'm going to do it. The length of BC is 3 times negative 12 plus 47, which is negative 36 plus 47, which is 11. So BC is 11. DE is 10. CD we can find by substituting x into either of these here equations, either this one or this one. Now, here's where the absolute value matters. Okay, notice how here when I do CD, it's not going to matter too much. You'll get the absolute value of negative 12 plus 16, which is absolute value of negative 4. Of positive 4, which is positive 4. So minus 2 times negative 12. So we'll get negative 20 plus 24, which is absolute value of 4, which is 4. So either way, you get 4. We're in good shape there. So CD is 4. So we have, I'll write 4 down here. So we need to add 11 with 4 with 10. So BE equals 11 plus 4 plus 10, which appears to be, what, 25? 25 units. Fiend.